Welcome back to my video. Today we will be discussing about type conversion and casting, arrays, console input and output, and formatting output. In the yesterday's videos, we have seen about control flow statements and jump statements. So now let's look into type conversion of a widening, wherein this widening occurs when one type of data is assigned into another, but they are of compatible types. That means the destination, let's say int is being converted into long. So in this type, widening occurs. So here the source is smaller and the destination is larger in size. So they both are compatible. Okay. So when int is converted into long and byte is converted into int, these are all widening conversions, and this occur automatically. The compiler itself will perform that. Now when you want to convert incompatible data types, then it comes under narrowing conversion. It performs under incompatible type of data. That means it has to be done explicitly by using this syntax. The syntax used for explicit typecasting is this. So wherein what we do, if we want to convert an integer into byte, we are having an integer variable a and we have a byte variable b. Now if we want to store this a into b, what happens? Integer is a larger in size, but byte is smaller in size. So when integer value is stored into a byte variable, there will be a lossy conversion. Some part of data will be lost. So that is about narrowing conversion. So if we try like this, if we directly write like this, this will throw an error. But to store an integer into a larger data into a smaller one, then we have to perform typecasting. Okay, we have to perform this typecasting, and this is called as narrowing conversion, and which it causes some lossy conversion. It leads to some data loss also. Now let's look into an example of this. Here we have a byte, an integer, a double. Okay, so now we are converting the integer variable into byte. We are storing that the integer into this byte. So what happens here? The value will be after conversion, after typecasting, the value stored into the byte will be 1. Now how did we get that? This is obtained by performing a modular division by 256. Okay, a modular division of that integer value. This particular integer value is modular divided by 256. So, and the remainder, and that value is stored into I. That is why, and that value is stored into b. So that is why we get the value 1 as 1 stored into b when we typecast the integer into byte. Now similarly, if we want to, we have d is double, the d variable is double, and we are typecasting it into an integer. We are storing that d variable into an integer. So what happens here? Here the rational part, the decimal part of the double variable will be deleted, will be truncated. So we get, this is the double variable, and after typecasting we get only 323. Now similarly, if we want to convert double into byte, when we convert double into byte, we have to typecast into byte. So this double value will be stored into byte. So here also it will perform what? It will perform the modulo division by 256, where 256 is the size of byte variable. It is the size of the byte variable. So this is how typecasting occurs in Java. Next is type promotion. So type promotion means like when we are storing an byte into integer, what happens? The byte will be enlarged. Here widening is occurring. So Java automatically promotes byte, short and character into integer while evaluating an expression. So in this case, what happens? We have a byte 3 bytes A, B and C, and we are storing its product into an integer D. So what happens? All these things will be multiplied and the result will be converted into integer and stored it into D. So let's look into some of the rules of type promotion. First, if they are all byte, the byte, short and character will be promoted into an integer. If one of the operand is long, then that whole expression will be promoted into long. If one operand is float, then the result of the whole expression will be promoted to float. And if one operand is double, the whole thing will be converted into double. Now let's look into an example of this. So here we have a byte 42, character A, short value, integer value, float and a double value. Now we are finding this product. So we have F as 5.67. So what will we get? 5.67 star B. What is B? B is 42. Then that whole thing plus I is what? I is character A. So its ASCII value will be taken, and into C you get C is character A and I is 5000. So you get 512. Then minus D is what? D is 0.123 and that into S is 1024. So you get this value. Okay. So when you perform F star B, we get this. Okay. Since F is what? F is a float and B is a byte. So when you find the product of F star B is the result of F star B is 238.14. Since F float is F is what? 5.67 and B is 42. Their product will be converted. It will be promoted. The type of the result will be promoted into float. That's why we still get the decimal part. Then I is integer and C is character. So C is storing the character A. So it will take the ASCII value of it, A's ASCII value, and their product is found and it is stored as an integer itself since character is of smaller size. Then D is double and S is short. So the result will be converted into double. The result type will be double. So you get 126 and final. So of all this is a float, this is int and this is double. So the final result will get it in double. So this is how type promotion occurs in Java. Next, let's look into how to read input and output from the console. Like how can we take all these examples we have been looking into taking the inputs directly from the program, but now we will be entering data through keyboard and the display will be shown in the output. So for reading console input, there are 3 different methods. One is using scanner class, the other is using buffered reader, and the third one is using console class. Now, using scanner class, what it does, the scanner class will read the data which is being passed through the keyboard. They will be converted into different tokens. They will be separated into tokens. The scanner class will read the input and it will be split into different tokens like keywords, identifiers, etc. And on what basis they will be splitting it? It is using the delimiter. There will be a delimiter to be used to split the whatever input string was read from the keyboard. Now this delimiter pattern may be either a white space. Basically by default white space, tab, new line, these are all considered to be white spaces, and by default white space is considered as a delimiter pattern. And also we can define our own delimiter pattern also. We can the user can define its delimiter pattern and also use scanner class. Now this is the syntax of scanner class, which extends the object class and it implements the iterator and closable interfaces. Then once these scanner class reads these objects, they will be converted into its corresponding type using the next methods. There are various next methods available in the scanner class. So for example, let us say we are reading 3 integers. So 3, then we'll give 3, 4, 5. So all these are delimiters. These carriage return forms the delimiters. So here we are pressing enter. So these are all these are all taken as delimiters, and so it will separate 3 as one token, 4 as another, and 5 as another token. Now once these values are read, they have to be converted into its, we are reading integers, so it has to be, now these are read as strings, now they has to be converted into integers. So it will use nextInt method to convert them into corresponding integers. Now let's look into a program which is being used, which is reading the elements through keyboard. So here we have our class name. Now since we are using the scanner class, we have to import that scanner class. Only then we can use these methods of the scanner class. So we this scanner class is available in the util package of Java. Okay, it is available. The scanner class is present inside the util package of Java. So we have to import that scanner class into our program. So to import the statement, we use the import keyword, import java.util.scanner. That means from the Java package, root package of Java, inside that we have the util package, and inside that we have the scanner. So we have to import this data. Now once they are imported, we can use those methods by creating an object of the scanner class. So to use the methods available inside the scanner class, we have to create an object for it. So this is the way we are creating an object for scanner class. Scanner is the class name, the object name, new keyword, scanner system.in. So this is the way we declare an object in Java. So we have to use the scanner class, we have to create an object of scanner class to read the elements from, to use the method of scanner class. Now let's first read the name of any student. Let's say we are reading the name of the student. So we are printing this string using system.out.print. Now once we enter these values, let's say the name of the student is ASD, we have entered that into the we have entered that element into the keyboard. So that so this scanner will be using the next line to read the string. Okay, it will read the string and that element will be stored into name. So we get name as name is equal to ASD. Next, now we are reading the hall ticket number. So this hall ticket number can be a combination of integers and characters. So if we are using, let's say 1995 1A0521, then what happens? This contains characters and integers. That is why we are using it as next line. We are reading it as string itself. So to read string, we use next line method. So using the object, and on that object, from that object you are calling the next line method to read the hall ticket number. So we read the hall ticket number as 1234. So we get into hall ticket number, say HT number, we have the 1234 stored. Next we are reading the phone number. Now phone number can be an 8 or 10 digit number. So we are using we have to use long. So to read long and convert it into long, we are using the next long method of the scanner class. So once you read this into the mobile number, into this variable mobile number, we have 1, 2, 3, 4, 5, 6 stored. And again, next is the CGPA. We are reading the CGPA, which is a rational, which could be a rational number which has its decimal part. So we are using the next double method to read the double value, and into CGPA it will store 4.5. Now these are stored into the memory by reading. Now what we are doing, we are retrieving these values and displaying it. So we have my name is name. So when name is displayed here, whatever content is stored into name is displayed over here. So you get the output as ASD. We get my name is ASD. So you will get this output. My name is ASD. Next is my hall ticket number is whatever is stored in HT number 1234, that will be displayed over here. So we get this line of output. Similarly, we get the other two. My mobile number is 123456. So we get this, and the CGPA is this. Now, once we finish the use of this scanner class object, you have to close it. So, this close method is present inside the closable interface. So we have to close it using the object. You have to close the object after use. So this is about scanner class. Next we have method by which we can read from the console is using buffered reader. It is using the buffered reader. So initially, initially in the early days, Java supported only byte stream of data. So everything will be read as byte stream. But nowadays, Java is allowing the character stream also. Character stream is also preferred over byte stream. So to read character oriented, we use buffered reader. Okay. Now so we here what happens is we have whatever data is being given through the keyboard will be read using the input stream. Okay, so this is the element which is reading the data from the keyboard. Now once this data is read, this data has to be converted into character. So to convert them into character, we use the input stream reader. So whatever data is being read from the input stream through system.in, all those bytes has to be converted into characters. So for converting that, we use the input stream reader. Now this buffered reader is used to buffer all the data which is being read from the keyboard. So instead of converting byte by byte, we can take up all the full complete byte and then store it. Okay, so the console input is accomplished by reading from the system.in, which refers to any input device, which is an input stream. The input stream reader converts the bytes into characters, which is read from the system.in, and the buffered reader supports a buffered input stream, hence improving the performance. So all the data which is being read through the keyboard will be buffered. So that is why when we are using this buffered reader, we have to wrap these input stream reader and system.in inside the buffered reader object. Okay, so we have to wrap the system.in in the buffered reader object. That is the reason we get this syntax of reading data through buffered reader. Now, their buffered reader is having, there are various type of constructors. Here, it will create an input stream. I mean, it will read from an input stream, which creates a buffered reader stream using a default buffer size. In this case, it will be using a default buffer size. But rather, in the second case, we will provide the buffer size. So, it will create a buffered character stream using this size of buffer. Okay, so these are the two constructors of buffered reader. Next, let's look into a program. So here, since we have to we are using the buffered reader, we have to import the buffered reader. Now this buffered reader may throw some exceptions. So because of which we have to declare the exceptions that could be thrown using the throws keyword. Exceptions, we'll look into it in detail in the later sessions. So since there are chances for these buffered reader and input stream reader to throw exceptions, we have to declare those exceptions before using the throws keyword. Then now we are creating the buffered reader object. Now these are the methods which are available inside them. So once first we are entering our name. So our name could be a string. Let's say we are entering ASDFGH. We are reading into name. We are reading this string. So to read string, we use the method in readLine. Now these methods are available inside the buffered reader. So you have to use the buffered reader object, and on that object using that object you are calling readLine. First we are creating the buffered reader object. First here we are creating the buffered reader object, and then using that buffered reader object you are calling the readLine. So once we enter this name, that name will be stored, this string will be stored into name variable, into the name, this string of type string. Okay. Then next we are reading the age. So into that age, we are reading, this is our age. So into age, this is the value being stored. Then next we have to read ID. So into now when we are reading age, see this, we have to keep a note of this. Whatever we give through the keyboard will be read as a string. Okay, they will be read as string. So we are embedding the that value which is being read as a string has to be converted into integer. So we are using the wrapper class integer and parsing method to convert the value which is read through keyboard. That string, we are intended to read some string. So the string which is read through the keyboard has to be converted into integer. So that is why we are using this integer.parseInt method. So this integer.parseInt method will convert the string, the 1, 2, 3, 4 string into integer 1, 2, 3, 4 and store it into age. Similarly, here also it will read the ID. It will read the ID. Here it will read the ID 1, 2, 4, 3, 2, 1, and that will be converted into integer and stored into ID. And we have the percentile as our percentile is let's say 12%, 12.34534. So that will be read as a string, and it has to be converted into double and stored into the double variable PC. Now these variables are storing all these contents and they are being retrieved and displayed over here. So finally you get the output as like this. Once you display, these outputs are whatever character was being value has been read from these keyboard, that they were stored into name, age, ID and percentile, and those are being output. Now the advantage of using input buffered reader is that it is efficient in reading, but since that code, that syntax is big enough, that wrapping code is, it will be hard to keep in mind, it will be hard to remember. So this was the drawback of using buffered reader, but using buffer, it enables efficient reading of characters. Next is arrays. Now what are arrays? Arrays generally store similar type of data. Like for example, it is a contiguous it will store data in continuous locations and they will be of same type. Say for example, these are all, this full thing form array. This is a continuous memory location and they are storing values of integer type. So whenever you want to store a set, like a group of like type of data, then we use arrays. We can use arrays. Now each of these array locations will be given some index. So generally the array index starts with 0. So this will be 0, 1, 2, 3, 4 likewise. So the data at array index 0 is 2. The data at location 1 is 4. The data at location 2 is 5. And these are all called as index. They are all called as index. And these are all group of similar type of data stored in contiguous memory locations. Now these arrays can be either one dimensional or it can be more than one dimensions. And we always access the elements of its array by using its index. So if we want to access the first, let's say this array is of name A, and if we want to access the fifth or the, let's say, second element, we use like this. Okay, this is how we access the array element. The name followed by the index. So any element in an array can be accessed by its index, and this offers a convenient means of grouping related information. Now let's look into the how we will declare the array. So to declare any array or to allocate memory, we use a special operator called as new. New is the operator which is used to declare an array, and they are always dynamically allocated, and it allows us to choose the array at runtime. We can choose the array length at runtime. So this is how we. This is one way of declaration. First we have to specify the type and its variable name. That means, for example, int month days. That means we are creating an array of integer type. And the the name of that array is month_days. So this is the name of the array and this is the type of the array. Then to that we are once we create some array type, then we have to give a size. Only then that size array can be created. So this size is given at runtime. So this is the syntax: array that variable array name equal to new int or the type and the size. So this is the example of creating. So we already created an array. Now that array is of size 12. The size of the array is 12. Okay. Now if we want to access one of the element, then we access it using that index. Also, this is one way. These two lines together form one way, and this is another form. Like we can specify together these two lines combined together. You can write it like this: type, name of the array, square bracket is equal to new int the size. So here we are creating an array of name, month, days of integer type, and it contains 12 elements. So this is an example wherein we are using an array month days, and these are the days of the months: January, Feb, March, like that. You have all the 12 days. Okay, 12 months of days of the 12 months. Now if we want to access, the April month. So this is we are declaring and we are initializing its value. So we will get an array with 12 elements, say 31, 28, 0, 1, 2, 3, 4, 6, 7, 8, 9. Okay, so we have array. This will create an array of 12 elements. Here we are not specifying the size, but we are statically giving the values of those arrays. The array in elements. We are giving the array elements statically. So these values will be stored into these locations. So here 31, 30, 31, 30, 31, 31, 30, 31, 30, 31. So while creating this, when a compiler execute this statement, we get an array created like this. Now we want to access the April month. So April month is the fourth month of the calendar. So, but since we have stored it in an array, April month being the fourth month, April is the fourth month, that will be accessed by third element. It will be at the index location 3. So if the April will be stored at, this is the value of April month. So that is why we have to access it by the value 3. Okay. So since the indexing starts from 0, every first element will be indexed as 0, second element will be indexed with 1, third element will be indexed with 2, likewise. So if there are n elements, then the index ranges from 0 to n minus 1. Once this statement is executed, you will get the output April has 30 days. So from month days 3 means it is 30. The value at location 3 is 30. So that value will be displayed over here. Come here and it will be displayed. Next is two-dimensional array. So two-dimensional array will be their array of arrays. They will be multi-dimensional. So you can have array of arrays. So when you create a multi-dimensional array, you have to specify both the dimensions. So they have to be specified in two parentheses. Two square brackets. We have to use another set of square brackets. So this is the syntax. So int 2D, so you are creating, this is the name of the array, this is the type of the array. We are creating array of type 2D with, since there are two set of square brackets, it indicates that it is a two-dimensional array, and int 45 means it indicates that this is a it is a two-dimensional array of four rows and 5. So here we are creating an array of 2 dimension which contains 4 rows and 5 columns. 4 rows and 5 columns. So to define a 2-dimensional array, we should use 2 set of square brackets. So let's look into an example program. Here we have defined the array. Then I, J and I and J are the iterator variables of the for loop. Since we have to enter data into an array, we use for loop. So if we are using 2-dimensional, we need 2 for loops. So now when let's say we have the I variable, I is pointing to the row and J is pointing to the columns. So initially this part will be 0, 0, 0, 1, 0, 2, 0, 3. Then 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1. So initially I starts, this is I and this is J. So I starts with 0 and J, initially I value is 0 and J value is 0. So when I is 0 and J is 0, 2D of Ij means 2D of 0, 0. 2D of 0, 0 means it is pointing to this. So it will store K. What is K? K is initialized to 0. So K value will be stored as 0 here. Next we are making K++. So K becomes 1. At this point, it has encountered the closure of for loop j. So since for loop j is closed, it will increment the j value. J becomes 1 now. J becomes 1. When j becomes 1, it will come to this location. So now k is 1. Into that, k value is 1. So into this 1 will be stored into 0, 1. So k value will be at 0, 1, the value 1 will be stored. K is incremented. K is now 2. Again, j plus plus. So j becomes 2. J becomes 2. So once j becomes 2, it will, this for loop will be pointing to 0, 2. 0, 2. So k is now 2. K is 2. So value 2 will be stored into, values 2 will be stored into ij. So at this point, 2 comes. Next k plus plus. K becomes 3 now. Uncounted j loop closure, j plus plus. So j becomes 3. Now j becomes 3. So it will be storing the element into 0, 3. So into 0, 3, the element 3 will be stored. 3 will be stored into element 0, 3. Next, so at this point, now j value is what? J value has become 3. J value has become 3. So again, j plus k value becomes 4 now. After making k value as 4, at this point j becomes 4. So into 0, 4, the element 4 will be stored. Then now at this point, j was 4. J is 4, and our condition is for 5. Now once this value is also entered, j becomes 5. So the condition here, the condition checking will be 5 less than 5. It is a failure. So this statement becomes false. This condition becomes false. So it stops the j loop and it will execute the I loop. I will be incremented. So I will become now, I will be 1 now. I will turn to 1. Once I is made to 1, again this whole j loop will be executed. So again j will start from 0 to 4. So once j is 0, it will be, the loading of data will be into 1, 0. I is 1, j is 0. So into 1, 0, the data is loaded. So here k was 4. Next value after incrementing k, after storing 4, k value had come to 5. So the data 5 will be stored over here. Once the data 5, then again j plus plus, k becomes 6. K becomes 6. K becomes 6. J is now 1 less than 5, true. It comes here. So into 1, 1. Into 1, 1. What happens? 6 will be stored. Into 1, 1. 6 will be stored. So 6 will be stored here. Then k value becomes 7. K plus plus, k becomes 7. Encountered closure, j is incremented. J becomes 2 now. 2 less than 5, true. It comes inside. Into 1, 2, it will store 7. It will store 7 into 1, 2. And k value will be incremented to 8. So it will store into 7 into 1, 2, and k is incremented to 8. Likewise, until j becomes 5, 8 and 9 will be stored. Now again at the encounter at this point, j becomes 5, that statement fails. So again I will be incremented. So I becomes 2 now. I becomes 2 now, and then again j will start from 0 to 4. It will go until 0 to 4, and all the elements will be stored inside. 10, 11, 12, 13. 10 will be stored here. 11, 12, 13, 14, 15, 16, and 19. So these values are stored over here. Now while retrieving, what happens? Again, we are using two iterator variables I and j to retrieve the elements. So I will go from 0 to I will go from 0 to 4. This is 0, 1, 2, 3. And I will go from 0 to 4. This is 0, 1, 2, 3. I will go from 0 to 4 and j will go from 0 to 5. So, it will start retrieving. So, when I is 0 and j is 0, it will access 2D 0, 0. So, 2D 0, 0 is what? 0. So, that value is printed here. Next, again here it will find the closure of j. Since we have only single statement, we need not use the the parenthesis, the curly brackets. But if you are having multiple statements, then you have to put them inside the curly bracket, or else it will take only the first line of statement. But here, since we have only single statement, we need not use the curly bracket. So it understands that after the statement, j loop is closing. So j loop will be incremented. J value will be incremented to 1. So next will be 0, 1. So 0, 1, 0, 1 will be taken. So 0, 1 means it is this element that will be printed. Then 0, next again encountered closure, again j++, 0, 2. This element will be taken and printed. Then 0, 3. 3 is taken and printed. Then 0, 4. 4 is taken and printed. At this point, j loop closes. So once j loop completes, once j loop completes at this point, it will print a new line. It is coming out of the j loop, but it is still inside the I loop. So before reaching the closure of I loop, it has to print a new line. So it will the control will come over here. The control will come here, and then I loop is incremented. So now I is 1. So I will start from 1 to from 1, and j will again go from 0 to 5. So 1, 0 first initially, j is 0, I is 1. So into 1, 0, the element is taken. 1, 0 element is 5. So element 5 is displayed. Then j++. So j becomes 1. So 1, 1 element at 1, 1 is taken and displayed. Then next again j++, 1, 2, the element at 1, 2 is taken. 1, 2 is 7, that is displayed. Then next is j++, again 3. So 1, 3, the element is 8, it is displayed. Next is 1, 4, the element is 9, element is displayed, retrieve and display. At this point, now j becomes 5, again j becomes 5, this condition fails, it comes out, it prints the new line, it takes the control to this line, it takes the control to this line. So again it starts from I equal to 2 to, I will go for, I becomes from 2, I is 2 and 0 to 5. Likewise, the other two rows are also printed. So once I becomes 5, at this point, once the fourth row is also printed, the I value becomes 4. So I 4 less than 4, the condition fails, it comes out of the loop, and when I becomes 4, it comes out of the loop, and the execution will be stopped. So this is about arrays, multi-dimensional and single dimensional. Now there is a special type of for loop in Java which is called as the for each loop. The for each loop is of this type. So it is mainly used to iterate over a collection of objects. It is used to go through designed to use over a collection of objects like arrays, or we have the collection interfaces also. So when we use the collection interface, the objects of collection interfaces, then there also we use the for loop, for each loop. So the general form of the for each loop is like this. So it specifies the type, the iterator variable, and which collection you are using, and the set of statements. So the type represents the type. This is the an iteration variable, and this loop repeats until all the elements of the collection has been obtained. So this is an example. So here we are statically reading the values. into the nums array. We are creating an array named nums, and into that we are storing 10 elements. And here we are finding the sum of the elements. Okay, so once these elements are stored, we can here we have to now retrieve those data. So the size, we are using the size of the array. So the elements in that, it can be obtained, the length of that array can be obtained using the length parameter, length keyword. The length of the array can be obtained using the length keyword. This is field of arrays. So nums.length means it will give the length of the array. So here there are 10 elements. So you get this as 10. Next we are reading the value. So we are using the for loop. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now it will go from 0 to, there are 10 elements, so the length will be 10, but the index will go to 0 to 9. Now we are starting with the first element, we are setting I equal to 0. So it is displayed where so you will get the output as value is nums of 0. What is nums of 0? Nums of 0 is 1. Now we have initialized some 1 as 0. So some 1 is equal to 0 plus, what is nums of I? Nums of I was 1. So sums I will store 1 now. So this will store 1. Next, bracket is encountered. So the for loop will be incremented. I plus plus. I becomes 1 now. So the value at nums 1 will be retrieved. The value at nums 1 is 2. So sum 1 will be 1 plus sum. This is like sum 1 is equal to sum plus nums. So sum 1 is already having 1. Nums of 1 is 2. So 1 plus 2, 3 will be stored into this. Now next is I value will become 2. At bracket is encountered, I value becomes 2. So at sum 1 plus nums of 2. So what you get? At 2 we have value 3. So 3 plus 4, 3 plus 2 we get 5. Now finally all the elements are retrieved and the output is taken, and you get the output like this. And the final value is 55. Now this is by the use of normal for loop. This is the use of normal for loop. Now let's look into the usage of for each loop. So in this is the loop. This is how we declare the loop. So int is the type of the array, x is the iterator variable, and we are using the collection nums, array collection, arrays. We are using the arrays. So from arrays we have to retrieve the values, right? So what you get, the value is x. So inside that array we have so this was our array. Now we start with x. So as long as there are value in nums, this for loop will execute. So initially it will be pointing to the first element. So we get 0. The value is 0. So you get the output value is 0. Then sum is equal to sum plus x. So sum was initially initialized to 0. So sum is equal to 0 plus what is the value at x? Value of x is 1. So sum is equal to sum plus 1. So you get sum is equal to 1. Next it will iterate toward the next element. So the element 2 will be retrieved. So x will contain 2, value here value is 1. So next element is 2, so value is 2. So sum is equal to 1 plus 2, which is equal to 3. So sum will be stored into 3. Sum will have 3. Next again it will iterate to the next element. So it will take 3 plus 3. You will get the sum as 6. Then 6 plus 4, 10. Like So next it will again iterate to the next element. It will add and store it into some. Next again it will iterate. So likewise it will iterate all the variables until it find the null string, or until you find that elements, there are no more elements in that collection. This loop will execute, and finally you get the output like this. So this is the output of using for each loop. Now there is some problem while using the for each loop. The thing is that we cannot we can only iterate over the collection. We cannot edit the collection using the for each loop. That means you are here. See, for example, we are retrieving the values, right? We are retrieving the values. We are retrieving the values, and we are multiplying that value into 10 and storing it back. So what happens here is this value in the array cannot be changed. Okay, we cannot change the values of that collection. We cannot edit the collection using the for each loop. You can only read it, only iterate over the variables. You cannot change it. You cannot rewrite it. So this iteration variable is only a read only variable. Okay, so the even if you change this value, we cannot, this change is not reflected onto the array. Okay, so here what happens, we are retrieving that value and we are multiplying it with x. So in turn, that is, we feel that it is converted into 10, into the product. But actually that is not happening. This iterator variable does not make any change on the underlying array. Now this is how we use the for each loop over multi-dimensional arrays. So we have to use two for each loops. Here we are already reading those elements. We are reading those elements into the array. We are reading the elements into an array, and then once we read the elements into that array, we are trying to retrieve it using the for each loop. So here it will be considered as a two-dimensional array will be an array of another array. So nums is the two-dimensional array. So we have nums here. We got 3. It is a 3 by 3 matrix. So we have 1, 2, 3. This is our array. Okay. Now once we read this array, when we start printing this array, we have to use two for each loops. So first it will read this array. This will be taken. This whole thing is num. So this part of this array will be taken into X. Okay. So from num we are reading the first one-dimensional array, and from that one-dimensional array we are reading the elements. So from this array X will be storing 1, 2, 3. So from elements 1, 2, 3, you have to iterate. So what happens? We are printing y, right? So once this this element will be taken, this y will be pointing here. Y value is printed, printing y value. Then sum of y is equal to, sum is initialized to 0, sum is equal to 1. Then y is next y is incremented and it is made to point to here. So 2 will be printed, 2 value is printed, and 1 plus 2 will be stored into sum. Then y is again moved forward, so it will come to 3. So 3 will be printed, 3 is printed, and 3 is added to sum. Now at this point, this array, X array is over. So it has to move to the next element, next. So it comes over here. So this whole thing will be stored into this X array. And again, we start with y iterator variable. So y will be pointing to 4. It will display 4 and add it to sum. Then again, it will go to the next element, 5. It will display 5, add 5. Then again it will increment to next element 6, it will display 6 and add it to sum. At this point, it encounters the closure of this loop, so it comes outside, and now it will print the new line, and then again the I loop, again x will be pointed over here, and x will be start reading these elements. So x will start with 7, it will display 7 and add 7, then it will increase, it will point to the next element 8, display 8, add 8, again display 9, add 9, once the y is moved forward. So with this, the sum will contain value 45 stored into it, and finally the summation is printed as we are printing the sum output variable as sum. So here we have to use 2 for each loop. So here also we cannot edit the whatever values is stored in the array using the for each loop. Now, so these are the few limitations of using a for each loop. We cannot use it to modify the array elements, and they cannot keep track of the index. For each loops cannot keep track of index, so we cannot obtain the array index for each loop, and it always iterates forward. You can move only forward, you cannot come backward. So these are the 3 disadvantages of using for each loop. So in today's video, we have discussed about type conversion and typecasting, that is narrow conversion and widening conversion. Then about multidimensional arrays, single dimensional and multidimensional array, how to use for each loop in for loop and for each loop in traversing arrays, and how to read and display contents into the output. So these 3 things we have covered in today's video. Thank you so much. We'll see you in the next video.
Like, share and subscribe. Hit the bell icon for more updates.